So yeah, let's get started. Sian, can you hear me? You're on mute. Just saying something. Sian, you are on mute. Ranjit, can you hear him?
Yeah, I can. No, I can hear
Hello.
him. Yeah,
No,
it's
no. But Sian, I cannot hear Sian.
Hello.
Yes, now you are audible. So, were you able to follow up the things that we were doing until now?
You mean like
You know, the progress,
previous?
whatever things list tuple on Python, whatever things we like last 2 days you were not around. So, did you get time to go through the things or take chat with Ranjit or someone?
I saw like what topics were covered, so it's fine. I've studied that before, so I think I
Okay.
can follow.
Let me know if you guys can see it. Can you guys see my screen?
yeah.
Perfect. So last day we covered these things. I'll just quickly go through functions. Last day we started, going into functions like what are they? And I have added a small picture here. So this will probably give you more context on what a function is and what are the parameters, what are the arguments and all of that. So, and how it works, a basic function body. So that is something that we covered yesterday. User defined and built-in function. So built-in functions are, so Ranjit, can you probably take us through the things that we covered yesterday? So it will, so we can probably ensure that you can remember the things that we discussed.
Yeah, yesterday I think we left out four types of arguments and lambda functions that we will be covering by today.
Absolutely. But the
Yeah.
things that we covered, so what essentially is a function? So if Sian asks you, what is a function? So how do you define it? Just give it a try. Say something.
Function means like sum of
No, sum is a particular type, like sum is a particular mode of operation. But what is a function? Like, so what industry you were in, Ranjit, like in your career?
medical.
Into medical, right? Okay.
Yeah.
So let's say a medical representative. So what is the function of a medical representative? The function remains same, which is to go to a doctor, medical practitioner, and probably pitch the product that a medical representative is working for, Cipla and Bexy, whatever, right? That's what a MR do. So if we try to correlate between these two, so what is the function of an MR is to go and do this set of things in front of a doctor. Number one, to tell the product. Number two, to talk about the benefits of the product. Number three, to talk about, the market capture and all of these things and so on and so forth. So basically, so if we come back to Python again, function is something which has already pre-written some set of operations that we need to do. So every time we don't need to write everything on our own. So we will define it only once, and for throughout our code execution, wherever we will be using Python, we will just call it. We will just call it. And what we will do in the red color, these are arguments. So we will just pass argument through it. Those argument will be catched by the parameters where exactly the function is defined, which in the picture here is A and B, and it will do the operation, whatever I want to do, and it will just give me the return. That's it. That's what essentially a function is. So just think it from a medical perspective. So MR's function is to do all these things, right? Go to a doctor, do this, that, that. So it's an iterative process. So if I take that MR from hospital A to hospital B, his speech, his talking, his everything will remain same, but the hospital will be different. So as per the different hospital, he will probably update the different things. So understand those individual hospitals and individual doctors are the arguments, and then they are getting captured as the parameter, and he is just doing his job, whatever needs to be done. Right, Ranjit?
Yeah.
You following these things, right?
Yes.
Just speak out if in case you have any, queries or anything at any point.
Okay.
So yeah, so that's what function is. So long story short, functions are something that will help us to reduce a lot of code writings. Like this, the simple one here, where I want to sum these two numbers. Imagine we have to do this 100 times in our code. So 100 times we have to just write this sum, all of that. Instead, what I can do it, I can define the function at one position and I can call the function, and that's it. Like the example that we were showing yesterday. So this function will convert uppercase to lowercase. This is what this function is all about. Now, every time we don't have to write this a dot lower. Instead, we will just call this function stri. We will just call this function. This is the function name and this is the parameter inside of it, and it will just do the lowercase on its own. That's it. So that's what functions are all about. Just it will help you to reduce your work. It will help to, take out the redundant and repetitive codes, from the coding workflow, not needed. So built-in functions are the ones which are. So Ranjit, can you just tell what are the built-in functions? What's a user-defined function? Ranjit?
Yeah,
Yeah. So can you tell us what's a user-defined, what's a built-in?
user defined function is like we can mention the name like hi, my name is Ranjit. Like
So user defined means a function that I will write, that an end user will write, a programmer will write. Like in this case, prnt, def prnt. This is an user defined function. Like here I have written def addition, def names. So these are user defined function. User have defined them. And then there are some built-in functions. Built-in means they are already written by Python developers. So the person who has developed Python has already developed these functions. I don't need to define it. I will just call it like print, range, length, all of that. So that's it about it. Now we will jump into four types of arguments. So yesterday we were just talking about one. Now, what are the four types of function arguments? There is a default, there is a keyword argument, there is arbitrary, and there is a required list or positional. Required or positional. That's it. So these are the different types of function arguments that we have. Now, what default is? So I have just been able to just write this just to save a bit of time. So default is something that assumes a default value if the value is not provided in the function call. Now, what is that? I have declared a function which is welcome that is supposed to get two inputs from the, while we will call the function. One is name, one is grid. Now, so this is where I'm just calling the function Ranjit. So the Ranjit is the first argument. It will go here, name, but I have not specified anything for grid. So if I've not specified, so by default, whatever is specified, as per the function definition, that will be used. So if the print here, what the print is just printing greet and name. So for the very first time, this is the result I'm getting, hi and the name Ranjit. But next time, if I just put the second argument as well, this will override hi. The hello will override hi, and this is the output I will get then. Hello Ranjit. So that's what default argument is. Default means if you specify some value, it will take that. If you don't specify some value, whatever value is there as part of the program, it's gonna take that. That's it. That's what default argument is all about. Like for few operations, there could be some situations where we just want the predefined value to be something like this. Can you guys excuse me? I'm just getting a call. It will take just 2 minutes. Just I'm going on mute. Okay, just give me 2 minutes. Yeah, all right. So that is what a default argument is all about. Now, in the next step, we will see what a keyword argument is. So keyword argument are things which will take, certain keywords. So like this will take certain values and based on that value, the name will be, so basically the function will be called accordingly. So where you have to specify this name. So this should be, the specific type through which you should pass the value. So ideally what we do, ideally when we call a function, we don't use the argument name, or the parameter name. We just put an argument. If it is number, then number, floating, character, integer, whatever. We just put that value and we just call the function. That's how we usually call. But for keyword argument, we have to mention the name so that the same name will be called and will be, the value, whatever it is there, this value will go into the same name itself. So there it will not be, overwrite or get mixed up or something like that. So that is what a keyword is all about, to maintain the sequence. See here, the idea is to allow the caller, that means somebody who is calling the function, to specify the argument name with values so that the caller does not need to remember the order. So what exactly is the order? Like first it has a greet, or then it has a name, or it's a reverse, or I don't need to know that. Just that's why I will just specify. So name is equal to John, because while like in case of range, so what we were seeing in case of a range function, we knew that it takes three arguments. First argument is the starting position, next argument is the stopping position, and next argument is the step position, how many steps. Now this order is something that I know I can remember, but what if I misplace this thing? I will get an error. So let's say if I say I have to start from 20, I have to go to 5, and I will take one step at a time. Now Python will throw an error because this is not going to work. How can I start at 20 and go to 5? I can start at 20 and I can go to 21. That is something I can do, but I cannot start from 20 and go to 5 with a positive increment. Now, on another note, this problem can be resolved if we make this as negative. In that case, this will work. We will start at 20, we will go till 5, and every time we will reduce it by -1. So first 20, next will be 19, next will be 18. So that way we can go, but we have to specify. Then only, the correct argument with the correct parameters, we need to bridge that graph. Then only that particular function will work. That is what this keyword argument is all about. So it is good to use the name itself, so we know what order or what, argument is going in what place. That is what keyword argument is all about. Next, good to know thing is a positional argument. So positional argument is pretty much similar with respect to the previous one. Here also the same thing, just that you don't need to specify particularly which, the John is going to either name or greet. You don't need to specify that. I mean, it's these two are pretty much similar, keyword argument and positional argument. So that is one thing, just that, the right position is needed. Like if, so this will work, but what if this John, this will not work because the function is expecting two positional arguments, name and greet, but I have given only two. Sorry, I have given only one. I should give another value for greet. So if I put another value for greet, then this will work. But instead, if I miss to put, the said number of positional argument, it will throw me an error. It will say one required positional argument, which is greet. I have not specified any particular value for the greet argument. Hence, the positional argument is something where you need to mention the exact number of arguments until unless there is a default value there. Let's say this one is default, like something that we saw in the default argument. We had a default value. So in that case, doesn't matter if we give all the positional arguments like we have done here. So we have given only one value instead of two, but it's not throwing an error because the second value of greet it's taking from the function itself, which is high. So that is what this is all about. And arbitrary argument are functions where you don't know how many arguments you are going to have at the end of the day. So it could be one, it could be more than one. So usually we write it with a star name. So until now, we were just specifying the name of the parameters, right? Name, greet, X, Y, Z, whatever. But here, I don't know how many values the user will enter. So I will just put it as star and just a loop to get all the values. So what it's doing, it is just iterating a loop to number of values name here is, let's say when we are calling the welcome function, I'm giving two values. So now by default, these two will take the shape of like this, name1 and name2. That will happen internally within Python. But that is something we don't need to know about how it works. We will just replace it with star and it will know, okay, as per the number of arguments has specified while calling the function, it has to rearrange itself and print it accordingly. So that's what, the four, so these are the four types of arguments that we have. Now moving on to lambda. Sian, any doubts, any question?
No, this is fine.
I cannot hear you. Can you speak a little loud?
No, I'm following.
Hmm?
I'm following.
Okay. So next we will talk about another function which is lambda. So what is that? So lambda is, if I put the definition, it's a just one line function, one line anonymous function which doesn't need to be defined. That's it. So this is one type of function where we don't have to define it. How? Let's see. So lambda of x such that x into x. Now, if we put like this, lambda of 5, argument of expression, argument and expression. That's how we write now. So C is equal to lambda x such that x star x. This is one thing. So what we will do here is we'll call C and 5. Yeah. Sorry, just doing it in tally. So yeah, so this is ideally how a lambda function looks like. So see the basic difference between a lambda function and a normal function. A normal function is something which we have to define first using def space function name and then the rest of the things. That is how you define a function. Then you have to call the function with specified number of arguments. So it involves multiple lines of codes. But for lambda function, what it does is it is essentially one line of code. So the way we write is lambda space argument. Argument means these parameters, this name, this name, greet, X, Y, Z, all of that. So X, comma, Y, let's say, and X star Y, and here 5, comma 6. So what this will do, so lambda X, Y are the number of arguments. After that, we have to put a colon marks here. And after colon, we have to put the expression, the statement, that what exactly I want to do with those arguments. Let's say I just want a multiplication of those two. So let's say this name is mult and I want to call mult and I want to see the multiplication between these two. So if I run lambda xy colon requires, oh sorry, it would be a comma. Yeah. So this is how a lambda function works. So lambda, then we have to specify the number of arguments that we have. And once the number of arguments are specified, after that, you just need to specify the operation that you need to do. So the number of arguments we have here, those many values we have to pass while calling the function. Now we have saved this, this entire lambda function into mult. So mult is essentially the name of the lambda function that I've created. So lambda itself is a type of function, but we have to give a name to the function. So the name is mult. So this is how we are calling. Now see the define the how what is the difference? Here we take multiple lines of code to define a function. Here we are taking only one line to define the function. Here one line to call the function, and here one line to call the function. And that's it. So that is the basic difference between that. So essentially, lambda functions are anonymous one-line functions which are meant to do some operations and which are meant to do some function work without defining that particular function, right? So that is what a lambda function does. So let's say there is something where I need to sum up three numbers. So sum of lambda x comma y comma z, so that I just want the sum of it, x plus y plus z, x plus y plus z. So this is the function, and if I have to call it, this is how I'll call it with three numbers, 5 comma 6 comma 7, and which will essentially be a sum of those numbers. That's it. Now why this lambda function came into the picture? So this is very important thing, and this is something we will cover later. So within Python, there are certain tables and some Excel type rows and column things. So there, those we call them as data frame. We call them as data frames, right? So those are known as data frames. So we call them as data frames. Now, within data frames, which are essentially something which looks like a Excel file, which has multiple rows and multiple columns. So you guys understood, right, what a row column is? Hello.
Yes,
So you guys understood, right, what we call a row and what we call a column?
row and column. So we understand lambda functions.
Data frame is like, yeah, data set.
Sorry, Sian, say again.
Yeah, I mean, data frame is like a data set, like with
Yes,
columns.
yes, yes,
Yeah.
yes, yes, yes. So a data frame is like a data set. So we have seen Excel, right? So this is how an Excel will look like. So these are rows, the horizontal ones. The horizontal ones, we call them as rows. And the vertical ones, we call them columns. So these are columns. So let's say this is a small table and it has some values inside of it, right? Yeah, let's say it has some values inside of it. These are some values. So if we say this is a table, within Python, we will call them as a data frame. Data frame is a table or a data set which has certain rows or columns inside of it. And this is how it will look. So these are things that we cover later. But right now, just understand the basic layout. So this is how it will look like. It will have, these are known as columns. So this is column one. First column is name, which has all names stored there. Second column has age. So age stored there. Age would be in like this. 2 2 3 cannot be an age. And something like this. So these are the age. Salary is something which will be like this. Okay. So this is how traditionally how a data frame or data set or table or something will look like. So in different language programming, architecture, we call them differently, but this is how traditionally they look like. Now, let's say I want to create a new column. I want to create a new column called flag, and I want to create an if else condition here. Like I want to see people who are getting more than 2000 rupees salary are high paid, and people who are getting less than 2000 rupees salary are underpaid. I want to create that flag. So how to do that? So in we know we can use if else. So within Python, what we have to do, we have to essentially write a function for that. So that function will have an if else condition. What will be if salary is greater than 2000, then we will call them overpaid, else we will call them underpaid. So this is the logic. Now, how will we write in Python? That's a different thing, but this is the logic, and this will be inside a function. Now, imagine doing this for a lot of operations. Let's say in a real world practical scenario, there could be lot of such scenarios where we have to deal with. We have to create multiple flags on multiple variables, multiple number of times. Now, for every time, if you have to define a function, declare it, run it, call it, then your code will be 1000 pages long. So what is the quick way around? Is a lambda function. So because lambda functions are simple, lambda functions are one-liners, and lambda function has two things. One is the list of arguments and the expression, what you want to do with those arguments. So quick fix, right? So let's say if we had to do the same thing here, how would have done it? So we would have just said like, flag, this is the new data frame column, flag column is equal to flag column is based on which column? Salary column. So first I have to select salary column dot within salary column. What are the things that I should do? I have to apply the lambda function. So I have to apply lambda. Now within lambda, X will be my salary. So here I have to put the expression, right? So here we were just doing a multiplication. That's why the expression was X into Y. Now here I have written only one because my input will be salary at a time. So only at a time I will just take one salary at a time, one value at a time. So I need only X. I don't need X, Y or something like that. I need only X. And the second will be your expression. So what will be the expression? This will be my expression. If salary is greater than 2000, then this, else this. So salary will be replaced by X. So what I have to write? If X is greater than 2000, then overpaid. Now, the way that we write in lambda is like this. So first we have to put the if condition. So it will be over if X is greater than this, else under. So this is a practical, application of a lambda function in case of a data frames, right? So this lambda function is very crucial in future because once we jump into data frames, which are essentially something which looks like this, for dealing with situations where we need to probably, manipulate one column, create new columns based on existing columns, existing more than one columns, two columns. So for those kind of situations, lambda is very much beneficial. Lambda function has major implications to deal with columns and to create new columns and all. See, here, whatever we have done, the whole thing is done in just one line of code. The column we will apply, then lambda x, only one argument, which is salary, that's why only one. And after colon, this is what I want to do. So the value is over if x greater than 2000, else it is under. That's it. So are we clear on this part? Sian?
Yeah.
Okay. And after lambda, we just talked about these two things, global and local variables. Now, global variables and local variables are essentially things where, it's about accessibility. So things which are inside a function that cannot be accessed from outside. Like, these names, greet and name. If you want to access them outside, you will not be able to do that because that is local to this particular function. So this is within the premise of this particular function area. It's more of like intranet and internet. Like, in college, we had LANs, right? In our, schools or colleges, we had LAN. So within LAN, we can access, or let's say intercom. So intercom is the best example of local variables. Because with intercom, you can, in a hotel business or let's say in hospital, with intercom, you can call from one floor to another, one doctor to another, one, room to another. But with the intercom, you cannot call somebody on outside the hospital or school network. That is not possible. So the scope is limited to the hospital itself. So that is a local variable. But mobile or telephone, these are global variables because you can use it to call anybody anywhere and anytime. So that's it. So that's the difference between local and global variables. So yesterday, Ranjit, if you remember, we had asked to work on one particular thing. So were you able to work on it using list comprehensions?
Yeah, so you asked me to do the prime numbers.
Yes, 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 yes.
It did like n is equal to, if it is 100 means like print number up to n, or
Okay.
receive of erotosens. So n is equal means it will give all of in 100 how many prime numbers is there, it will give the number prime numbers.
Yes. So were you able to do it?
Yeah.
So can you just share it with us? Let me stop sharing. So just share your screen and yeah.
Able to see?
Yes, I can. So what was the requirement? So let me just ping you there. So just copy paste it from the chat window.
I taken support.
Hmm?
I taken some support.
No, that is fine, absolutely. But as far as you understand the logic,
Yeah.
so can you tell me? So see, you have done a lot of codings and all, but understand what you have done. That is the first thing. Were you able to tell me what exactly you have done? This is lot of codings and all. I totally get it. The numbers are right, absolutely. But what exactly this is all about? So, Sian, yesterday we were just talking about, writing a function which will take user inputs, and after that it will, the user will tell, let's say 50. So the function will give you all the prime numbers up to 50. Let's say in instance, the user will say 100. So the user, the function will give all the prime numbers up to 100 like that. So that was the need. So Ranjit, would you be able to help us understand what you have done? Because see, copying it from somewhere would not make a sense until unless you can debug it. Debugging is a crucial step during your, career or work. Let's say tomorrow, if you work somewhere, you will be asked to do this logic. And once you will do it, everybody will come and say, brilliant, it works. But if somebody asks you, or let's say the client asks you, like Ranjit, help us understand what is this, or we want to make some change here. So if you are able to make that change, then absolutely fine. Doesn't matter where you have copied the code from. But if you're not able to make the change on the code that you have written, then that will give you a very wrong impression to the client, to the team members, to managers, to everyone. So the thing that I say always is always copy the things which you know you can take care of. Don't copy things which you are not aware of or would not be able to manage.
Okay.
So just try, help us understand now what is doing. Let's just try something.
So if you are taking this n, so agenda is 100. So n is equal to 100. So now
Right.
we want only the prime numbers. So print prime numbers up to like n numbers. So which means 100. So like n comma it's r sleeve of erythrosense means it will give all the prime numbers.
That is fine, but what is happening in the prior line?
Which line?
What is happening in the prior line? So that one, yeah.
This
What is
line.
happening there? Yes.
So it is giving true. If the number it is prime numbers means it will true. So n plus 1.
Yeah, and why are we doing all of that? Like n in the next line in the for loop, there is a range which starts from 2 and then n into so that means n to the power. So there are two asterisks, two star signs means that is to the power. So n to the power 0.5 plus 1. So why are we doing all of that?
This I don't know.
Yeah, so that is the point. So we should copy the things which we know and confident about. Okay, let's do one thing. Let's tell me the what is the basic logic of a prime number. What is the basic logic of it?
P
Like why are we
asking
saying 2
one.
is a prime number? Why are we saying 2 is a prime number? Sian, can you tell us?
Uh, 2 is a prime number because it is only divisible by 1 and itself.
Exactly. So if Sian, if you have to write it in a logic using if and else, what will you do?
Uh,
So just tell this to Ranjit and Ranjit just open a new cell. Just click on the plus button and open a new one. Just add a new cell here. Right. Now just, yeah, just write there. Perfect. So just write if, see and just tell what exactly we have to check. Let's say
yeah,
the
the
number is X. Let's say the number is X.
yeah,
So
then x should only be divisible by 1 and x.
X.
All the
Exactly.
other
X.
numbers should
Exactly.
be
So
divisible.
Ranjit, so can you tell Ranjit, so what exactly we should write it or how exactly we should write it? Just the logic, not the exact code I'm looking for, just the logic. So that is divisible by number and X. Let's say X is the number.
Yeah, if a number is divisible, it means like when you divide by that number, the remainder will be 0.
Yeah, exactly. That is the point. That is the point. Ranjit, you got that right. So if we divide a particular number, we will call it perfectly divisible if the remainder is 0. Like
0.
nothing is there. So in Python, we use the modulus operator for that, which is percentage. So just write if X percentage 1 X percent. No, after that, after x, if x percentage 1 equal to, so that's how we check if two numbers are equal or not. One single equal to is an assignment operator and two equal to are checking operator. So this is equal to 1 and x percentage x, sorry, is equal to 0. Sorry, I also made a mistake. So x% 1 is equal to 0 and x% x is equal to 0. Two equal to's. X percentage x. No. Okay, just go at the starting. So what we have written, if x percentage 1,
1 equal to 1. And
no, it will be 0. It will be 0. So equal to 1 means it is not perfectly divisible. We are getting remainder 1. That means 6 percentage 5 will give you 1. Because if we divide 6 by 5, we are getting 1 as remainder. But we don't want that. We want remainder to be 0. And similarly, x percentage x, 2 equals, just put one more equal to sign. Yes, is equal to 0. Then prime. So that should be a logic. Then this is a prime number. So this is the logic. Now we have to write a function which can take care of it. Now there are two things that we should look into. First is x is, let's say it's an any number. It could be any number which the user will provide. It could be 100 or even more than that. So the first thing is 1 is not a prime number. So we have to write that logic as well. And we can probably hard code it. Because 1 is only divisible by 1, nothing else. Right? So first logic will be if x is equal to 1, then this is not a prime number. Else, if what the whole thing that we have written, then this is a prime number. And this whole thing has to be inside a loop. Now let me share my screen. Right. So this is what we were just doing. So assignment was first take a list of whole numbers. And yesterday, so there is one important concept that we covered, CN, which was list comprehension. So until now, we have seen how to create a list using, manually just putting all the numbers. But it's not possible all the time because there could be a list based on a certain condition. How we will do that? Or let's say I want a list of 1,000 numbers. So it's not possible for me to write, all the numbers 1, 2, 3, 4 like that until 1,000. So there is a concept for list comprehension which goes like L1 is equal to X. This is the value for X in range of 10. So if I do this, what this will do, so for X in range 10 will run a loop 10 times. And each and every time, whatever the value of X, it will start from 0, it will go till 9. So every time that will be my value of the list for that particular time. And then it will move to next one, it will move to next one like that. So if I run this and see what is the value, this is what I'm getting. So this will create a list of all the numbers. So what I need from user is this value. So user will provide me this value. So user will provide me this num is equal to, that is something that user will provide me. And I just need to replace it here. That's it. Now, once this part is done, what we need to do, define a function to calculate on prime number. So that is the important part. So def prime prime. So I need to have a value here. So let's say the value is A. Now, if A is equal to 1, Guys, just give me a moment. I'm getting another call. Just give me a moment. Yeah. So, the logic that we were seeing earlier. So, if A is equal to 1, then return, or let's say this thing, just put a print here. Or let's not do anything because we need only the prime number. So we don't need if the number is prime or not. So we're not bothered. So we will just say if a percentage 1 is equal to 0 and a percentage a is equal to 0, then we need to store it. So let me create, let's say, a blank empty list I have created. So pr dot append of a. So this value will be appended here. Put it this way. This is a prime, that's the number now. If the first thing that we need to do is if that number is more than 1 or not. If that number is more than 1, then let's say that number is 10. So we need to iterate it 10 times. So for I in range, now this little bit of code was there as part of Ranjit's code, but we have to understand what is happening. So we have to iterate it. Now, how many times we have to iterate it? So if the number, okay, let's just, let me see what this thing does first. 6 by 3. So this is a simple division, right? So what this is, so this is the this divided by, so 6. So if we put 2 equal sign, it's telling you this is the divisor, the the factor which helps to do the perfect multiplication. So what is there? I mean, there is one remainder and there is a this thing. So if we put 7 here, so 7 means 3 into 2, 6. So I will get 2 here, like that. So based on the number, first we have to see how many times we have to iterate. So if the number is 9, so we will start from 2. By default, the first 2 will be eliminated. And how many times we have to proceed? So in that case, we have to proceed till number divided by 2. So it's a, there is 9 divided by 2 plus 1. So we have 5 times we have to iterate. Let me write it down and then let me help it. Then I'll explain. Just let me write it down. This one first. This for I in a range of 2 to this. Let me just print it. Print of A. Let's see what are we getting. Prime of 10. If I do like this, what will I get? So it's giving me 10 because every time the last, okay, so this is 10, but if I print I, what I'm going to get? Yeah. So this is what I am going to get. So if, see what's, it's taking 10, 10 is going as input. So if 10 is greater than 1, for, then within that we are running a loop. Now this loop starts from 0 till this is the range. So it starts from 2 basically, because that's the initial position that we have specified. And A divided by 2 plus 1. So A is your 10. So 10 by 2 plus 1, which will give you 5 plus 1, 6. So it will start from 2 and go till 6. So eventually the loop is repeating 4 times. That is what the objective is. Now, out of that, I have to see if that particular number
Come again,
is
I didn't get it.
okay. Let me just wrap it up then. Just 1 second. Just give me a moment. Let me just finish writing first. So if a percentage I is equal to 0, then you print a print not prime or something like that. A this is not prime, and that's it. It will exit from the statement. Else here a is prime. Else print is not prime. Dash, that should do it. Here quotation mark. Yes. Let's try with 9. Oh, I think this is wrong. 9 is a prime number. What about 13? Yeah, 13 is a prime number. 9 is not a prime number. Yeah, I think it's working. 11 is not a prime. 11 is a prime number. 12 is not prime. Perfect. So, this is how usually it works. Now we have to go step by step what exactly it's happening. So the first thing that we are doing is, this is the way that we have to define a function. Ranjit Sian, is it okay if we close today right now, because I have to go and pick my son from school?
No problem.
Yeah,
We
sure.
can.
Okay. Okay, thanks. Yeah, thanks for understanding. Today we couldn't spend a lot of time, but tomorrow we will start from here. So meanwhile, I'll just just have that look on your end, and I will explain in what this. Okay, let me upload it into the Git link,
Hmm.
and then you can just take it, and
Okay.
I will just take you through what exactly we are doing tomorrow. Meanwhile, if you are able to understand, but it's pretty simple. If it is more than one, then only we are considering those numbers. And just this part is important. This part you have to understand, like why the loop is running 5 times. So
Hmm.
that is something that we need to understand,
Okay.
right? So yeah, so we are having, let's take a hard stop today. And tomorrow we can do some coding, if that's all right with you. Yeah, so this part will be over. So tomorrow, whatever we have learned until now, so we will just do lot of codings tomorrow, right? And then we will start with this particular segment. So this will be until this week.
Okay.
So Thursday, Friday. So for this week, so tomorrow we will do some coding practice on our own using list, tuple, loops, functions, everything. Like
Okay.
let's say sample code could be, if enter your date of birth and you have to tell whether that person is eligible for a vote or not. So we will see those kind of codings tomorrow. And once that is done, then by the end of the day or by Friday, we'll try to work on this one, Python modules. That will take us to a good shape. Okay. So we are having a hard stop today. Thank you guys.
Thank you.